Hello everyone. In this video, we'll be solving problem 119, Pascal's Triangle 2. The problem statement is, we are given an integer row index. We need to return the row index row of the Pascal's triangle. Please note that it will be a zero indexed value. If you're not familiar with Pascal's triangle, each number is the sum of the two numbers directly above it. Let's look at this example to understand it better. Because the input is zero indexed, the first row, its corresponding index will be 0, then 1, 2, 3, and 4. The value for 0 or row index 0 will be 1 by default, and for row index 2, it will be 1, 1. Another way to look at it is the value of this element is the sum of the two elements above it, which is this on the right hand side. As there is nothing on the left hand side, we'll consider it as 0. So 0 plus 1 gives us the value 1. Similarly, for this element, it's two elements above, so the 1 on the left and 0 on the right, which gives us 1. This is the same pattern for all the elements on the edges for each row. Because there is nothing on the outside of the previous row, the value will always be 1. The elements in the center is where we need to calculate. So for this element 2, to calculate its corresponding value, we'll add the two elements above it, which are these two ones, which gives us 2. Similarly, for this element, the two elements above are 1 and 2, which gives us 3, and so on and so forth. So we need to return the corresponding value of the row after we build the Pascal's triangle. I hope you were able to understand the problem statement. Before we dive into whiteboard, there's one follow-up requirement that is given to us. The problem statement is asking us to optimize our algorithm to use O of row index extra space only. We'll try to solve this keeping this requirement in mind. As we were calculating the values earlier to understand the Pascal's triangle, you may have noticed to calculate the value, let's say for row 2, we are relying on the values right above it, which is row 1. Similarly, for row 1, we were relying on the values for row 0, and for row 3, we wanted the values for row 2. So basically, we need to make sure that we are having the values stored in a variable which we can use to calculate the values of the middle elements in each array. By default, we know that for row index 0 and 1, the values are going to be fixed. So we can just hard code those. So let's start with row index 2. For row index 2, my previous is row index 1, so I'll save its corresponding values in the previous array. As we don't have to calculate the values in the corners, we can default it to 1, and we need to only calculate the values in the center. So the formula should be current of I is equals to previous of I plus previous of I minus 1, which means for this value, its corresponding I will be 1. So the formula will be previous of 1 plus previous of 0. So adding those will give us 2, which we can save. There are no more elements left in the array, so we'll continue the next one. Let's try for row 3. Here we have 2 elements. Please note that for every row, the total number of elements in the array are the row index plus 1. So for row index 3, the total elements are 4. For 2, it were 3. To calculate the values at this position, its I is 1. So the values will be previous of I, which is value 2, and previous of I minus 1, which is value 1. So the total will be 3. We'll save it here. Similarly, for this position, the I value is 2. The I value is 2. So my calculation will be previous of 2 plus previous of 1, which are these two values. So the total will be 3. We'll continue the iteration until we have calculated all the array elements for the row index that the problem statement is asking for. With this approach, our time complexity is O of n square, where n is the row index, and the space complexity is O of n, as we are only maintaining this one variable to maintain the calculation for the previous row index. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by checking if the row index is equals to 0. If yes, then I'm simply returning an array with one entry, value 1. Then I'm initializing the previous array with the values for row index 1 with having two values, 1 and 1. If the row index input that is given to us is 1, then I'm returning previous here. and exiting out of the method. If not, then I start the for loop starting with I is equal to 2 until I is less than or equal to row index. I'm calling this iterate method, which helps us build the array for the particular row index. And this iterate method takes the input of the previous calculation that we have done, initializing the current array, setting the first and the last element to the value which was there in the previous element. Then I start the for loop for the elements in the center and using the formula calculating the values. After the for loop is complete, I'm returning the current array. After receiving the current array, I'm saving it in the previous array, which will be used in the next run. After the for loop is done, the value for the particular row index will be saved in the previous array, and which is what I'm returning at the end. This code, when submitted on LeetCode, beats 100% of the submissions made so far in terms of runtime complexity, and in terms of memory consumption, it beats nearly 51%. Thank you for watching this video. I hope you were able to understand this approach and the solution. If you have any questions, feel free to reach out to me. The link to the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.